Hello students, let's continue with exercise 2.5 of polynomials, which is based on algebraic identities. So we are on the third question, wherein we need to factorize the following, these sums using appropriate identities. Now what does factorization mean? We need to write this term into the product of its factors, right, reducing to the lowest form. So let's look at our first question, which is 9x square plus 6xy plus y square. Now we need to factorize it, right? So we will have to twist and turn so that it resembles one of these identities. So initially we are going to compare. Now let's see, we have a square term at the first and square term at the last, and there are three terms. And there is another term in between, which is a product of the first and the last term in a way, okay, and we have a plus sign. Now which one does this resemble? The first identity itself, you have x square, y square as positive, and a term in between, which is having both x and y, and all the signs are positive. So I am going to rewrite this in such a way that it resembles my first identity, right? So let us first split 9. 9 can be written as 3x. I'll just do it over here. So this is 3x the whole square plus, we need a 2 over here, right? So I need to split 6 into a product of 3 factors, which is 2 and a value of x and a value of y, right? So this is going to be 2 into 3x into y. So does this resemble 2xy over here? Yes, it does, right? And then we finally have y square. So now we are going to use our identity 1 and solve this. So I will say using, now first of all, we have x and y over here, so I am not going to write my identity in the form of x and y. I will write it in the form of a plus b, just replacing the variables x and y with a and b respectively. Okay, using a plus b the whole square is equal to a square plus 2ab plus b square, right? Now we already have this portion over here. We need to write it in this format, right? So I'm just going to swap it, okay? So therefore, this is equal to a square plus 2ab plus b square is equal to a plus b the whole square, right? Therefore, my value of a when comparing to this question, the value of a is 3x and my value of b is y, right? Therefore, I will write, I have 3x the whole square plus 2 into 3x into y plus y square is equal to a plus b the whole square. So my a is 3x, right? So 3x plus b, my b is y plus y the whole square. So this is not my final answer. I need to rewrite this in the form of the question, right? So I have 9x square plus 6xy plus y square is equal to 3x plus y the whole square. And finally, I'm going to box this up. Please take a look. Let us proceed with the second sub question, question 3. My question 2 is 4y square minus 4y plus 1, right? Now again, let's check and compare with our algebraic identities. The first term is a square, the last term is 1, which can be written as 1 square. So even this is a square. And in between you have a product of y and 1. That is we have y over here and 1, right? And there's a negative sign here. So this resembles my identity number 2. But before I proceed with solving the sum, I need to rewrite this sum, agreed? So I'm going to rewrite 4y square minus 4y plus 1. 4y square can be written as 2y the whole square, correct? Now for the second term, I need 2 first. So I'm going to split 4y into 2 y into 1, right? This gives me 4y plus 1 the whole square. Now we can solve this using our algebraic identity number 2. So I'm going to say using a minus b the whole square is equal to a square minus 2ab plus b square, right? I'm going to swap this and rewrite because we have already been given this form, correct? So this is a square minus 2ab plus b square is equal to a minus b the whole square, right? Therefore, what's the value of my a? The value of a is 2y and b is 1, correct? So let's go ahead and solve the question, which is 2y the whole square minus 2 into 2y into 1 plus 1 square is equal to a minus b the whole square, which is 2y minus 1 the whole square, right? So let's go ahead and rewrite the answer in the form of a question, which is 4y square minus 4y plus 1 is equal to 2y minus 1 the whole square. And finally, I am going to box up my answer. So with this, we have solved question number 2. Let's proceed to question number 3. I have x square minus y upon 100 y square. X square minus y square upon 100. Now let's see. X square can be written as x square upon 1 or x square upon 1 square. But we don't really need to rewrite it because we are not going to find the LCM over here. We need to solve this, that is, write it into the product of its factors using algebraic identities. So we have two terms here, right? We have two terms here, x square minus y square with a negative sign in between, right? X square minus y square. But what do we do about the 100? Let's see, we can rewrite this as x square minus y upon 10 the whole square. Now does it resemble x square minus y square, which is identity number 3, right? So I am going to say using a square minus b square is equal to a plus b into a minus b, right? So what I have done is rewritten my identity in the form of a and b instead of x and y, right? Therefore, I have my a is equal to x and b is equal to y upon 10. Therefore, my sum becomes x square minus y upon 10 the whole square is equal to a plus b. So x plus y upon b right, and a minus b. So x minus y upon 10. This is y upon 10. Right. So we have solved the sum. However, we need to write it in the form of question and answer, right? So I'm going to rewrite my question. X square minus y square upon 100 is equal to x plus y upon 10 and x minus y upon 10. So with this, we have completed question 3, wherein we factorize the sum into product of its factors using algebraic identities. Okay, we'll continue with question number 4 in the forthcoming lecture. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.